So this is a circuit that we are going to construct using Tinkercad. Okay. So I have opened the Tinkercad website. Okay. So I hope you guys have opened it too. Right. Just get it ready over here. Okay. So in this circuit, how many nodes do you see?
3.
3. Actually, there are 4 nodes. I think you forgot this one. Okay. So let me just label as A, B, C, and D. Okay. So this is B. All right. So we want to measure the current in this direction. Okay. And we want to measure the voltage across your 10 kilo ohm. Right. So what I'm going to do is, let's start with the circuit design. So first you have to include your breadboard. Okay, so if you cannot find your breadboard, for example, I have this breadboard already, but just in case you want to find it, just type breadboard. Okay, and you just click, it will appear on your screen like this. Okay. Okay, so you can see the letters here and you can see the numbers, but I like to make the letters to be at the top. Okay, like this. Okay, so that each row represent a node. Okay, so you can see here, all these holes are connected. Okay, underneath, it means that this is one connection lah. Okay, so I want to connect this 5 kilo ohm connection between A and B. Okay, so I want to define node A and node B. All right, so I need a resistor. Okay, so there's a resistor here. Okay, normally I like to horizontalkan dia. Okay, so I cannot put it like this because this one means that you are short circuit the resistor because you are connecting it with the same node. Okay, so you can put it like this. Then this is correct, means that this is node A and this is node B. Means that row number 1 is my node A, row number 5 is my node B. Boleh follow You guys can follow?
Yes, madam.
Okay, all right. However, I want to make it horizontal, so I cannot put it like that, so I'm going to put it like this. Okay, because you have this gap here, so this row number 6 on this side is not connected to this row. So I can say this is my node A and this is my node B. Okay. Okay, so next is you define the value. So value there is 5 kilo ohm. Okay, so I'm going to say here. Okay, because the unit, there's ohm, there's mega ohm. Okay, but we want 5 kilo ohm. Right, so that's done. Next is the power supply. Okay, so I want to do the connection for this 10 volt. Okay, so this 10 volt is connected between A and B as well. So for power supply, you just type power. Okay, so there are a number of battery, cell, but if you go down, you can see the power supply. Okay, so that's my power supply, and the voltage is 10 volt, right? So you don't have to change anything with this current value. Okay, just leave it as it is, but just change the value of the voltage. So that's done. And you can see here there's a red knob and a black knob. Okay, so this red knob means positive terminal and black is negative terminal. So the positive terminal should be connected to A. So where's my node A? This one, right? So I just click and you will see a wire coming out, and you click again so that you can move the wire and click. So connect to row number 6, because row number 6 is my node A. Okay, so normally for positive terminal, I put as red color. You can change the color of the wire. Okay, so next is my node B. Okay, the negative terminal should be connected to node B. So let me click here and I just drag. Some student managed to make it so beautiful, but I'm just going to do like this. Okay, so this is my node node B, and I'm going to put color black. It means that you are connecting it to the negative terminal. Okay. What you can do as well, if you want to make sure that you are connecting it to the right node, is you can do this annotation. Okay. So annotation means you can put a node. So for example, in this case, I put R6, which means that row number 6, okay, is my node A. I can do that, right? And then this one, I can put a node as row 6 prime. Why I put a prime? Because it is for this side, okay, this portion of my breadboard. So row 6 prime is node B. Okay, so you can label your node. That's one thing that you can do. Okay, boleh follow so far?
Boleh, madam, insyaAllah.
Boleh, madam.
Okay, good. So I've done these two connections. So now I want to add the 2.5 kilo ohm. So this guy is connected between A and D. Okay. So A is this node. I'm just going to add another resistor. Okay. So this is my node A. So I just bring it here. All right. So my node A is this row, right? So this will be 2.5 kilo ohm. Okay. So now I can define this as my node D, right? So this is R, what R is this? R10 kan? Yes, it's R10. Is my node D. Okay, so you can do that. So that's done. Now this resistor is between B and C. So I'm going to define another node. Okay, so just add another resistor between B and C. Okay, so this is my row 6, node B, and this is my node R10 prime. This is my node C. Okay, so all your 4 nodes have been defined. Okay, but still not finished kan? We still have one more component, which is my 5 volt. Okay, so my 5 volt, another power supply. Okay. Here. So this will be 5 volt. It's already defined here. Okay. So the red cable should be where?
C, 10C.
C.
Kan? Okay, that's correct. The red cable should be at C. So just gonna put it at this row. Okay. Okay. Okay, and the negative cable will be at node D. Okay, which is this guy. Okay. Right. So that's done. So your circuit has been constructed. Okay, so you've done your circuit. But, oh, not yet. I forgot something. I need to define the resistor. So the resistor is, I should have defined that. So between B and C is 10K. Oh, okay, I forgot about that. Okay, so just double check, 2.5, 5K, and 10K, right? Power supply is 5 volt and the 10 volt. So your circuit is complete, okay, but you want to measure the current and the voltage. So you going to insert an ammeter into the circuit kan, in order to calculate in order to determine the current, okay. So, okay, so this is my current direction, all right, in the question kan. It means that you have to put the red cable for your ammeter, for your DMM at this point. This one should be your red cable, and the black cable should be at the pointy part of your ammeter. So your ammeter has a red cable, and so your ammeter dia ada ni juga macam power supply tadi. So one is red and one is black. Your ammeter must be connected in what? Parallel or series with the path yang you nak measure the current?
Series.
Yes, correct. It should be in series kan. So I want to put my ammeter over here. Okay, so you can put over here as well, no problem. But let me just put it here. So you are putting another device to that particular path tau. It means that this 5 kilo ohm is no longer connected to A. Initially it was like this, right? So you can see the 5K directly connected to A. But now, as you insert emitter, the 5K is connected to another node. So you have to define another node, and I'm going to call this node as X. Okay, so the current is this way. Okay, so my node X will be connected with red cable or black cable.
Red.
Asal red pula?
Black cable.
Black.
Yeah. It should be, my emitter is kat sini. You just imagine ada emitter kat sini. Okay, so the pointy part is my node X. So my node X will be my black cable, and node A ni will be my red cable. So it means that this my 5 kilo ohm ni will be become like this. Alright. So if you go back to Tinkercad, okay, so this is my 5 kilo ohm, which is now connected to node A. I need to define another node for my 5 kilo ohm. Okay, so what I can do is I can move this guy to another row. Okay, this one maintain as my node A, right? And now this row, okay. So now row number 2, I will define it as my node X. Okay, this is my, okay, row 2 will be my node X. Okay. So because the other 5K, the other end of my 5K here, okay, must connected to node B. Still connected dengan node B. So you can see here, okay, still connected dengan node B kan. So my node B is here dekat row number 6. So how can I bring these two connection together? Okay, so that's why we use a term called jumper. Jumper ni you just basically you put a wire, you just drag to the particular node. So maknanya now I already define this node as node B. Jumper ni I like to maintain a different color than red and black. Okay, basically you are connecting this row and you are defining this row as node B because of this connection. Okay, so next is my multimeter. Okay, so in order to add multimeter, you just type multimeter here or multi, and it will come out kan. So it's already here. Okay, so the default mode is voltage, but I want it to be emitter kan. So you have to choose emitter, or in this case amperage. Gitu. Alright. So you can see, as I mentioned just now, ada black cable and the red cable. So that's what I want to show here lah. Okay, ada red cable and black cable. So the red cable should be at my node
A.
A, betul. So my red cable should be at node A, which is at ni. Okay, should be red. And my black cable should be at node X. Row number 2 tadi kan. Okay. Okay, so what's next? The other parameter you're going to measure is the voltage across your 10 kilo ohm. Okay, so voltage is very easy. Okay, you don't have to do anything with the component. You're just going to add the mm, right? So for voltmeter, you just going to put connection macam ni across kan. So voltmeter is in parallel tau. Okay. So the red cable is always at the positive terminal. So depends on the question. The question say positive on this side and negative at this side. So the positive will be my red cable, the negative will be my black cable. So you're gonna have a reading that is macam ni jugalah. Same way as the notation in the question. So red cable will be at node B, the black cable will be at node C. Okay. So voltmeter is straightforward. So I'm just going to add another voltmeter kat sini. Okay, so this is already in voltage mode, so I don't have to change anything. So red cable at node B. Okay, just like in the picture tadi. Okay. And my black cable will be at node C kan. Okay, so I know it looks messy, so that's why you have to do it slowly. Okay. So B and C, your voltmeter. Okay. So now you are ready to simulate. Okay. So when you want to simulate, you just start simulation. So the answer is 2 milliampere, and the voltage across your what is the resistor there? Is negative. So it's okay. Your voltage has polarity and current pun ada direction. Okay. So your current has direction means if you got a negative answer means that the current is at the other direction. Okay. However, if the question put the arrow like that, you just follow whatever reading you get. Okay, because you have to, you are answering the question kan. So in this case, based on the arrow, the current is 2 milliampere. Based on the polarity in the question, the answer is minus 12. So later in your experiment, this is the reading you get kan. So how can you confirm whether the reading is correct or not? That's where you have to do your theoretical analysis. So in this case, you can do nodal or you can do mesh. So that will be in your discussion part. So that is what we are expecting from you for this lab. Okay. So I'm not going to show you the theoretical calculation. You can do that later lah kan, just for practicing. Okay. So, but I know the voltage will be negative. So if the current flows in this direction, the polarity for that particular resistor will be plus and minus. Okay. So in this case, the power supply, the current from the power supply will flow in this way. Okay. From positive terminal kan. So my current flows this way. So my voltage across 10K should be plus and minus. However, the question is like this. That's why we got a negative answer. Okay.